The National Electrical Code generally mandates that distribution blocks be placed in accessible locations within an enclosure or panel. However, there are exceptions permitted under certain conditions. Regarding placement on the side of an enclosure, an exception exists. Distribution blocks may be placed on the side of an enclosure if the wiring space within the enclosure is insufficient or if the distribution block itself is too large to fit on the panel. If you are putting a distribution block on the side of the enclosure, there are requirements. Firstly, the enclosure must be specifically designed for the type of distribution block being installed. Secondly, the distribution block must be securely fastened to the enclosure and readily accessible for maintenance and inspection. Thirdly, adequate working space must be provided around the distribution block for safety and ease of access. As for including contactors and breakers in the same enclosure, contactors and circuit breakers can be installed in the same enclosure as the distribution block provided certain requirements are met. Firstly, the enclosure must be large enough to accommodate all the components including the distribution block, contactors, and circuit breakers. Secondly, all components must be properly spaced to prevent overheating and labeled clearly for identification. Thirdly, adequate ventilation must be provided to prevent overheating of components, and easy access to terminals must be available for testing and maintenance. Specific code references pertain to the placement of distribution blocks and other components. NEC Section 312.6. B states that distribution points must be accessible after installation. NEC Section 408.3. B stipulates that enclosures for overcurrent protection devices and switches shall be designed so that the cover will not be opened unintentionally, which is to prevent accidental contact with live components. Additional consideration should be taken into account when installing distribution blocks and associated components. From a safety perspective, distribution blocks, contactors, and circuit breakers should be installed in a safe manner to prevent hazards such as electric shock or fire. Wires should be properly insulated, and connections should be torqued to the manufacturer's specifications. With code compliance, always consult with local authorities and inspectors to ensure compliance with all applicable building codes and electrical regulations. These codes may vary depending on your location. When choosing the location of the distribution block, consider the ease of future maintenance and inspection. Ensure that the distribution block is easily accessible for troubleshooting, repairs, and routine inspections. Some more things to consider. First, conductor selection. Ensure that the conductors used with the distribution block are properly sized for the applied load and are suitable for the termination temperature of the distribution block. Second, overcurrent protection. Provide appropriate overcurrent protection for the conductors connected to the distribution block to protect against short circuits and overloads. Third, torque requirements. Always follow the manufacturer's torque requirements when making connections to the distribution block to ensure a reliable and safe connection. Fourth, environmental conditions. Consider the environmental conditions of the location where the distribution block is installed, such as temperature, humidity, and exposure to corrosive substances. Choose a distribution block that is suitable for the specific environmental conditions. Fifth, labeling. Properly label all circuits connected to the distribution block for easy identification and troubleshooting. Sixth, strain relief. Provide adequate strain relief for all conductors connected to the distribution block to prevent stress on the terminations. Seventh, grounding. Ensure that the distribution block and enclosure are properly grounded to provide a safe path for fault currents. Eighth, conductor bending space. Comply with NEC requirements for conductor bending space at the distribution block to ensure that conductors can be properly installed and terminated. Ninth, accessibility. Ensure that the distribution block is accessible for inspection, maintenance, and future modifications. 10th, qualified personnel. Only qualified personnel should install and maintain distribution blocks and associated electrical equipment. Now let's delve deeper into the NEC sections mentioned and other relevant considerations. Regarding NEC section 312.6. B. Accessibility is key. The intent of this section is to ensure that all electrical components are readily accessible for inspection, maintenance, and repairs without requiring extensive disassembly or removal of other equipment. This accessibility allows electricians and inspectors to perform their duties safely and efficiently. Consider a scenario where a distribution block is buried deep within an enclosure, behind other equipment, making it difficult to reach. This would violate NEC section 312.6. b. Instead, the distribution block should be mounted in a location where it can be easily accessed with standard tools and equipment. Now looking at NEC section 408.3. b. Unintentional opening of enclosures can be hazardous, potentially exposing personnel to live electrical parts. This section requires enclosures to be designed in a way that prevents accidental opening, such as using latches, screws, or other secure fastening methods. The design should ensure that the enclosure remains closed under normal operating conditions, even if subjected to vibration, impact, or other external forces. For example, an enclosure with a flimsy cover that can easily be knocked open would not comply with this section. The enclosure should have a robust design that requires intentional effort to open, thereby reducing the risk of accidental exposure to electrical hazards. There are many additional considerations, and here are some important ones. Firstly, short-circuit current rating. Ensure that the distribution block has a short-circuit current rating sufficient to withstand the available fault current at its location. This rating should be clearly marked in the distribution block. Secondly, insulation voltage. Verify that the insulation voltage rating of the distribution block is suitable for the system voltage in which it is being used. The insulation voltage rating should be greater than the maximum voltage that the distribution block will be exposed to. Thirdly, material compatibility. Ensure that the materials used in the distribution block are compatible with the conductors being terminated. For example, if using aluminum conductors, the distribution block should be rated for use with aluminum conductors. Fourthly, terminal type. Select the appropriate terminal type for the conductors being terminated. Common terminal types include screw terminals, compression terminals, and spring clamp terminals. The terminal type should be suitable for the size and type of conductor being used. Fifthly, wire size range. Verify that the distribution block can accommodate the range of wire sizes being used in the application. The distribution block should have clearly marked wire size ranges for each terminal. Sixthly, environmental protection. If the distribution block is being installed in a harsh environment, such as a wet or corrosive environment, select a distribution block that is specifically designed for those conditions. This may include features such as corrosion-resistant coatings and waterproof enclosures. Seventhly, listing and certification. Ensure that the distribution block is listed and certified by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association. Listing and certification indicate that the distribution block has been tested and meets applicable safety standards. Eighthly, installation instructions. Always follow the manufacturer's installation instructions when installing the distribution block. The installation instructions will provide important information about proper installation techniques, torque requirements, and other important considerations. Ninthly, periodic inspection. Perform periodic inspections of the distribution block to ensure that it is in good condition and that all connections are tight. Loose connections can cause overheating and electrical hazards. Tenthly, documentation. Keep accurate records of the distribution block installation, including the manufacturer's name, model number, serial number, and installation date. This information will be helpful for future maintenance and troubleshooting. Let us consider some practical examples to illustrate these points. Consider a scenario where an electrician is installing a distribution block in a control panel for a large HVAC system. The electrician needs to ensure that the distribution block is properly sized for the load, that it is installed in a location that is easily accessible for maintenance, and that all connections are properly torqued. The electrician also needs to verify that the distribution block is listed and certified by a recognized testing laboratory. In another scenario, an electrical contractor is installing a distribution block in an outdoor enclosure for a lighting system. The contractor needs to select a distribution block that is specifically designed for outdoor use, with features such as corrosion-resistant coatings and a waterproof enclosure. The contractor also needs to ensure that the distribution block is properly grounded to protect against electrical shock hazards. Now let's discuss some advanced topics related to distribution block placement and installation. Firstly, harmonics. In electrical systems with nonlinear loads, such as variable frequency drives and LED lighting, harmonic currents can be present. These harmonic currents can cause overheating and other problems in distribution blocks. When selecting a distribution block for use in a system with harmonics, it is important to choose a distribution block that is rated for harmonic currents. Secondly, voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its impedance. Excessive voltage drop can cause equipment to malfunction and can also increase energy consumption. When installing a distribution block, it is important to minimize voltage drop by using conductors that are properly sized and by keeping conductor lengths as short as possible. Thirdly, surge protection. Surge protection devices are used to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. When installing a distribution block, it is important to consider the need for surge protection and to install surge protection devices as necessary. Fourthly, power quality. Power quality refers to the characteristics of the electrical power being supplied to a load. Poor power quality can cause equipment to malfunction and can also increase energy consumption. When installing a distribution block, it is important to consider the power quality of the electrical system and to take steps to improve power quality if necessary. Fifthly, energy efficiency. Energy efficiency is the ratio of useful energy output to total energy input. Improving energy efficiency can reduce energy consumption and lower operating costs. When installing a distribution block, it is important to consider the energy efficiency of the electrical system and to take steps to improve energy efficiency if possible. Sixthly, renewable energy. Renewable energy sources, such as solar and wind, are becoming increasingly popular. When installing a distribution block in a system with renewable energy sources, it is important to consider the unique characteristics of these sources and to select a distribution block that is compatible with them. Seventhly, smart grid. The smart grid is a modern electrical grid that uses advanced technologies to improve efficiency, reliability, and security. When installing a distribution block in a smart grid system, it is important to consider the requirements of the smart grid and to select a distribution block that is compatible with them. Eighthly, electric vehicles. Electric vehicles are becoming increasingly popular. When installing a distribution block in a system that includes electric vehicle charging stations, it is important to consider the unique requirements of these stations and to select a distribution block that is compatible with them. Ninthly, data centers. Data centers are facilities that house large numbers of servers and other computing equipment. When installing a distribution block in a data center, it is important to consider the high power density and cooling requirements of these facilities and to select a distribution block that is compatible with them. Tenthly, industrial automation. Industrial automation systems use computers and other technologies to control and automate industrial processes. When installing a distribution block in an industrial automation system, it is important to consider the requirements of the automation system and to select a distribution block that is compatible with them.